And welcome back to the morning show. It's Wednesday, 6:50, a wise guy time. Our U of I physics professor Matt Sellen is back from a little trip to New York, right?
Yeah, doing some research at Cornell over there.
Very good. And you brought some water back?
Yeah, you know, there's nothing like New York water. I'm just kidding. You know, champagne water is fabulous.
It's perfect.
And what made me think of water is that it's been so gosh darn hot, and you know, everybody's jumping in the pool and
I was there yesterday. It's a good place to be.
Man, isn't that great? And so, you know, sometimes you wonder what makes things sink and float. And what happens sometimes, you know, you can make yourself float by breathing in a lot of air, and then maybe you can make yourself sink by just exhaling.
Pushing it out.
And then sometimes you've noticed that if you try to pick up something out the bottom of the pool, it doesn't seem to weigh that much because it's underwater. Okay, and so there's a really easy way to explain all this stuff, and it was figured out a long time ago by a guy named Archimedes, and it's Archimedes' principle, which tells us how things float, basically, and it's called the buoyant force. And what it is if you put something into a liquid like water, it pushes water out of the way. So, for example, just look at the level of this pool right now. This guy to pretend this is a swimming pool.
Okay.
I'm putting my finger right at the edge of this thing where the water level is, and if I put this thing in, which is a person, have to pretend, okay?
Gotcha.
What you see is that the water level goes up a little bit, maybe half an inch, and then the person kind of sort of floats, okay? Now, there's an upward force on this thing, obviously, because when it's in the water, it's not falling down anymore. It's just floating at the top, whereas if you hold it out here, it weighs a couple of pounds. It's pretty heavy, okay? And so this upward force is the buoyant force, and it's really easy to figure out what that is. It's just equal to the weight of the water that this thing pushed out of the way when it was put in the water. Okay? So we can demonstrate this by using these things. I've got 3 little cylinders here made of different stuff. The first one's made of aluminum. And if I put it on this little scale, you can see that the weight of this thing is 8 newtons. This thing measures weight in newtons, which is a measure of force. And if I stick it underwater, you see that it reduces to about 5, okay? So that means right now the water must be pushing up on this hunk of aluminum with a force of 3 newtons. But that's exactly equal to the amount of water that this thing pushes out of the way. Right, so if I figure out how much water could fit inside a space like that, that's how much it would weigh. So now I have another cylinder which is exactly the same size, but you'll notice here that this thing only weighs about 3 to start with. Okay.
So it should be what, 1?
Right, so when I put this thing underwater, you'll see that once again the water pushes up with about 3 newtons, and so you're left with about nothing.
Wow.
Okay, so this thing weighs about the same as water, this plastic does. And here's a piece of styrofoam that has hardly any weight at all.
Probably, right?
It doesn't weigh much at all, this thing. Okay? So basically nothing. So if I shove this thing underwater,
it's going to be tough. It's pushing back.
It's pushing back up now with a force of 3 newtons, but this thing doesn't weigh that much, so gravity doesn't pull down on it very much. So what happens is it just pops up. And what you're left with when the thing is floating is, if you just look really carefully on kind of an edge on, you'll see that about a quarter of an inch of this thing is underwater. And what that means is that if you figured out how much water it had pushed out of the way by being just a quarter of an inch into the water, the weight of that little slice of water is exactly the same as the weight of this thing.
Oh, cool.
So anything that floats displaces its own weight exactly in water.
Very good. You paint it red and use it as a bobber.
That's right. You could go fishing with this thing, and so that's why people kind of float, more or less, because people are mostly made of water. So they're going to weigh about as much as their own weight in, their own volume in water.
Very good.
And so this bottle is like a person, and it kind of floats, and you can make yourself sink by hanging on to heavy stuff, or float by taking a big breath of air.
Works for me. All right, what do we got coming up?
Well, when we're coming back, I have a surprising thing about floating and sinking. I'll do a demonstration that people can try at home.
All right, very good. We'll check that out when we come back. If you have any questions for the Wise Guy, email him to the morning show or go to his website. Now let's get a check of weather.